Welcome to Quest to Physics. In this session, we are going to talk about what is meant by dipole and what is the dipole moment. And also, we derive an expression for the torque acting on a dipole which is kept in an electric field. Okay, students, let's start with the meaning of the dipole. First of all, we have to understand what is meant by dipole. Pole. Okay, students, a pole means here having one type of charge. Di means two. Okay, this dipole itself telling us that it consists of two charges. It consists of two charges. Let's say one such charge is negative charge. Okay, students, I named it as minus q. Okay, students, and we have one more charge. It is the positive charge. And has a magnitude of plus q. See, students, these two charges being separated by certain distance. Okay, students, these two charges being separated by certain distance, the two if at a fixed distance. Okay, students, if two charges being separated by a certain distance, this arrangement is said as the dipole. Okay, and condition is these charges must have the same magnitude. Maybe their polarity is different. Here, if you watch it, you will find it is a negative charge and it is the positive charge. They're being separated by a certain distance and it consisted dipole. That means I'm joining the center of the charges. Okay, students. And it is a fixed distance between the centers. Let's locate a point here. I'm calling it as the O. And say the distance between the center to the negative charge is L. And this one is L again. Okay. The distance is equal to it. And this arrangement is known as dipole, students. Dipole means two charges being separated by a fixed distance. Okay, the magnitude should be same. Now a question will arise, students. Does an atom is a dipole? Atoms generally have the positive and as well as the negative charges. The answer is certainly no. The answer is certainly no, students. Because if you take an atom, this positive and negative charges have a common center, students. Okay, students. That's why atom is not at all a dipole. Okay, students. Now we are talking about dipole. I explained you. The two charges, okay, are being separated by certain distance. It is known as dipole. Then the term which is related to this dipole is the dipole moment. Dipole moment, students. Here we have to understand what is the dipole moment is. Dipole moment. It is a vector quantity, students, and shown with the letter P bar. Okay, students. What is the dipole moment? Mathematically, we can write dipole moment P bar is equal to magnitude of the charge multiplied with the distance between the two. Charge multiplied with the distance between these two charges is known as dipole moment. Okay, students, P bar is equal to Q into 2L bar. It is a vector quantity, students, and has the units of, what are the units? As a user, you know that charge is measured in coulomb. It is meter. The unit of dipole moment is coulomb into meter, students. Well, students, what is the dipole moment? It is the product of charge multiplied with the distance between the two charges. That is, the units are coulomb meter. Okay, students, already learned that the units of dipole moment is coulomb meter. The next important thing in dipoles is the direction of the dipole moment, students. You can remember it very easily. When we talk about the electric field intensity, you have learned that the direction of the electric field intensity is from positive to negative Z. Here in this case, dipole moment, the reversal of electric field intensity. I mean, the direction of the dipole moment is from negative to positive, students. See, from negative to positive is the direction of dipole moment. Whereas electric field intensity is always from positive to negative. I told you why atom is not a dipole. Now maybe you understood. Here if you go with the dipole moment, P bar is equal to Q multiplied with the length. Here if you take an atom, in atom, already I explained, the centers of the positive charges and as well as the negative charges coincide with each other. Do remember this, students. Atom is not at all a dipole because the centers of the positive and negative charges coincides with each other. Means what? The 2L, the term 2L here is equal to 0 in case of an atom. That's why it's not at all a dipole. Yes, students. I hope you understood that. And next, students, we are going to learn about the torque acting on a dipole which is kept in an uniform electric field, students. As you learn that electric field, I mean electric field intensity or electric field flux density. These all have the same meaning. These all have the same meaning, students. And I showed E bar is the symbolic representation of the electric field and its direction is always positive to negative. Okay, students. And also you have learned that dipole means what? If the two charges of equal magnitude I said, equal magnitude being separated by a certain distance, the two a fixed distance. It's now we are going to find out the torque acting on a dipole which is kept in an uniform electric field. First of all, we have to understand what is the torque is. Students, you have already learned that torque is nothing but the turning effect of the force. The turning effect of the force is known as the torque, and you have learned that in first year of intermediate. Torque is written mathematically as tau bar is equal to R bar cross F bar. Maybe you remember that. Torque is nothing but the turning effect of the force. Okay, students. Here, say it is a uniform electric field. Is that uniform electric field? You know that what is the electric field is? What is the electric field? It is the amount of force acting on unit positive charge which is kept in a field, students. That is known as the electric field strength. Electric field is the amount of force acting on unit positive charge. We call it as electric field strength also, students. Here it is the field, and you know that the direction of the field is here it is. It is negative to positive. Just imagine. Negative charge is here and the positive. And charge being moving, that is the negative charge from here to here. Okay, students, the uniform field. And what is the uniform field? Where the strength of the field is same at all places. Uniform field means what? The strength of the field is same at all places. Such kind of field is known as uniform electric field. Okay, students, now what we are doing? We are taking a dipole and we are keeping in an uniform electric field. Okay, students, let us assume it is the one of the charges and it is one more charges. Okay, students, let's say it is the negative charge and it is the positive charge. Okay, students, and it is making an angle of theta with the field lines. See this. Okay, students, it is the field due to a larger charge, and say it is plus, and it is the minus, it's the minus q, and it is plus q. And these charges experiences a force, students. These charges experiences a force. Okay, students, the direction of the force here along this, on this positive charge, is this, and its magnitude is F bar. The same way, for this negative charge, the force acting in this direction, we call it as F bar. Okay, students, when a charge is kept in an electric field, it experiences a force, and you have learned that force F bar is equal to E bar multiplied with Q. Okay, students, here this F bar is nothing but E bar into Q. Here it is also equal to E bar into Q, students. These two forces constitute a couple, students. These two forces constitute a couple. What's the couple? Two forces of equal magnitude acting in opposite direction constitute a couple. And we have plenty of examples of that, students. Churning of the milk is one of the examples of couple. And handling the handle of a bike is the couple. One force acts in this way, another could be in this direction. The same thing is happening here, students. One force, this force, is trying to rotate this dipole along this direction, and the other is in opposite direction. Okay, let's say the length between the charges is equal to 12. Okay, students, here I'm dropping a line from the positive to here, and a join. Then you will see a triangle here, students. Okay, students. Now I am resolving this length into components, students. Okay, I am resolving this length 12 into components, students. If it is theta, automatically it is a theta. If you watch this, you will get a right angle triangle here. Okay, students. It is. Then it can be written as it is 12 sine theta. And this other component is 12 cos theta. Okay, students, we'll learn about the resolution of the vectors. Okay, firstly, we will understand. If we say it is a vector, any vector, say it is f, body is a vector, and making an angle of theta here. This one is the x and is the y. Okay, we are resoluting. Means what? Dividing a vector into components. And here it is f sine theta, and it is f cos theta. Because we constructed a triangle, and you know that sine theta is equal to what? Say it is O, it is A, and it's the B. Sine theta is equal to AB by F. Here AB is the component of force. We call it as the Fy, and here it is Fx. The same way cos theta is equal to OB by F. This way. In this way we took it as 2L sine theta. And I told you torque is nothing but perpendicular distance multiplied with the force. See this, it is the force and it is the perpendicular distance. To get the perpendicular distance only, we, what is that? Divided this 2L into two perpendicular components. Then you can write torque, tau bar. What is the perpendicular distance? I am writing the magnitude. It is 2L sine theta multiplied with force. Okay, students. Okay, R. You can write torque is equal to 2L into F sine theta. It is the amount of torque acting on the dipole kept in an electric field. And it can also be written as, you know that force is equal to EQ. I am writing the magnitudes only. And further it can be written as torque is equal to 2L into EQ into sine theta. And you know that Q multiplied into 2L, okay, is said as P. And torque can be written as PE sine theta. Okay, students. It is the expression for the torque, students. Then after we have to find when the torque is maximum and when it is minimum. Okay, students. So in other words, you can write torque is equal to P bar cross E bar. And you learn that. But if you multiply the two vectors, vectorially you will get P bar cross B, A bar cross B bar is equal to AB sine theta. Similarly, we got it as P sine theta. Then after we will find when the torque is maximum and when it is minimum. Just imagine that the turning effect is happened and this dipole is arranged parallel to the electric field. This dipole is arranged, that means came into equilibrium along the direction of the electric field. Then we can say theta is equal to 0. Okay, students, theta is equal to 0. And theta is equal to 0, then what is the torque? See this. Torque is equal to PE into sine 0. This 0. And we call it as the minimum torque. And then we will find the maximum torque. Obviously, when theta is equal to 90 degree, torque is maximum. Okay, students. Torque is maximum when theta is 90 degree. Then you can write torque is equal to P into sine 90. Sine 90 is equal to 1. And maximum torque, tau max is equal to P. Okay, students. The dipole experiences maximum torque when it is perpendicular to the electric field, students, like this. And minimum when it is along the direction of the electric field. I hope you understood what is meant by the torque. Okay, students, and what is the dipole and as well as the dipole moment. If you like the video, please forward this to your friends and don't forget to subscribe it. Please.